Okay, here we go with page 4. We're moving over to particle motion. The position of a particle moving along a straight line at any time t is given by this function right here. This is our position function. What's the acceleration of the particle when t equals 4? Well, we know that our acceleration function is the second derivative of our position function. All right, so let's get our first derivative. S prime of t, well, this is a nice quick derivative, 2t plus 4. And now we need the derivative of that first derivative. By the way, what's this called? Yep, that's velocity. Good. And the derivative of 2t plus 4 is just 2. So the acceleration is always 2. All right, with number 12, a particle moves along the x-axis with this position where a and b are constants and a does not equal b. For which of the following values of t is the particle at rest? Okay, so a particle is at rest when its velocity is equal to 0. So we need to get the velocity function, which means we have to derive the position function. So this is one of those where they give us a position function and they use x of t instead of s of t. Right? But it doesn't really matter what letter they use for position. We still need to derive it. Right? So you can do this through a couple ways. You can do a product rule. You could also FOIL or multiply these two binomials and then take the derivative. I might as well use the product rule here. So v of t, derivative of the first, t derives to 1, and a is a constant. It's a number. That's what we're told right here. A and b are constants. So a will derive to 0. So we end up having 1 times t minus b. That's derivative of the first times the second. Plus, now we keep the first and take the derivative of the second. And again, t derives to 1, and b derives to 0. All right, so what do we end up having for velocity? We end up having t minus b plus t minus a, or 2t minus b minus a. And we're interested when this velocity function is equal to 0. So we got to solve this function for t, which means we got to move the b and the a over to the other side. All right, so we end up having 2t is equal to a plus b. And then we divide by 2, and we see that t is equal to a plus b over 2. Our answer is A. And one more particle at rest function. This time we're given a cubic, so we need our velocity function, our first derivative. All right, so we derive t cubed to 3t squared, and 3t squared becomes minus 6t, and minus 9t becomes minus 9, and the plus 1 becomes 0. So there's our first derivative. Again, we're interested when the particle is at rest. So we set this velocity function equal to 0. I see right here I've got multiples of 3 galore, so I'm going to factor out a 3 just to make my factoring a little bit nicer, like so. And what's going on here? This is a quadratic trinomial, so I need two numbers that multiply to negative 3 and have a sum of negative 2. So it looks like I'm looking at t minus 3 and t plus 1 equal to 0. All right, so now we start covering them up. This will produce t is equal to negative 1, and that will produce t is equal to 3. And I don't have to worry about the 3 because 3 is never equal to 0. So there's the two answers that we come up with, t is equal to 3 and t is equal to negative 1. However, at the top of the page, we're told that t's domain is the non-negative numbers. So this one is out, and we're only interested in 3. So the answer is B.